Let's start by rewinding a bit. In the early days, applications were often built as one big system, a monolith. But as technology advanced and user demands grew, these monolithic systems became harder to manage and scale. Developers began breaking them down into smaller, specialized services. Each service focused on a specific task, like handling orders, processing payments, or sending notifications. The shift made systems more flexible and easier to update, but it also introduced new challenges in how these services communicate and share data. As applications split into microservices, each service started to operate independently. For example, an order service would need to talk to a payment service, which might then interact with a notification service. Analytics teams wanted data from all these services to understand user behavior. This independence brought flexibility, but also complexity. Suddenly, there were many moving parts, all needing to communicate reliably and efficiently. The system became more dynamic, but also more fragile if not managed well. So many services talking directly to each other, things can quickly get messy. Imagine if one service goes down, suddenly, half the system might be affected. Debugging these tangled connections becomes a nightmare, and scaling the system is even harder. Each new service adds more complexity, making the whole architecture fragile. This is a common pain point in modern software systems, and it's exactly the kind of problem that needs a smarter solution. This is where Apache Kafka comes in. Kafka was created to address the chaos of direct service-to-service communication. It acts as a central hub for messages, allowing services to communicate without being tightly coupled. Instead of sending data directly to each other, services send their messages to Kafka. Other services can then pick up these messages when they're ready, making the whole system more robust and easier to manage. At its core, Apache Kafka is a messaging system, but not just any messaging system. It's designed to be incredibly powerful and flexible. Kafka allows applications to send data, store it safely, and let other applications read that data whenever they're ready. This means services don't have to wait for each other or even know about each other's existence. Kafka becomes the meeting point where information is exchanged smoothly and reliably. Instead of services talking directly, they send messages to Kafka. Kafka stores these messages safely, and other services can pick them up whenever they need. This decouples the services, so they don't have to wait for each other or worry about who's on the other end. It's like having a shared mailbox where everyone can drop off and pick up information at their own pace, making the system more flexible and resilient. Think of Kafka as a common meeting point for all your services. One service can drop off information, and multiple other services can come by later to read that same information. Each service can move at its own pace, without being held up by others. This approach makes the system more scalable and easier to maintain, since services are no longer tightly connected. In Kafka, the service that sends data is called a producer, and the one that reads data is a consumer. The producer doesn't need to know who will consume the data, and the consumer doesn't care who produced it. This separation is what makes Kafka so powerful. It allows for true independence between different parts of your system, reducing dependencies and making it easier to scale and evolve. Kafka was originally built at LinkedIn. The team there needed a way to handle massive amounts of data coming in constantly, with many different systems needing access to that data at the same time. Traditional databases and message queues just couldn't keep up with the scale and speed required. So, Kafka was designed from the ground up to be fast, scalable, and reliable, even when things go wrong. LinkedIn's challenge was clear. They needed to process huge streams of data, all the time, and make it available to many different systems. Existing solutions couldn't handle the load or provide the reliability they needed. Kafka was created to fill this gap, offering a way to move data quickly and safely between services, no matter how much data was involved. Kafka stands out because it's fast, scalable, and reliable. It's designed to handle high volumes of data without slowing down. Even if part of the system fails, Kafka keeps running, ensuring that no data is lost. This reliability is crucial for modern applications that can't afford to lose important information or experience downtime. One of Kafka's most important features is its ability to keep data safe. Messages are written to disk, so they're not lost if something crashes. They're also replicated across multiple machines, adding another layer of protection. And if a consumer needs to, it can go back and reread old messages. This makes Kafka a great fit for systems where data integrity and reliability are top priorities. Kafka is especially useful in modern architectures like microservices, event-driven systems, real-time analytics, and streaming data pipelines. It provides a simple, reliable way to move data between services, making it easier to build systems that are both powerful and flexible. Whether you're processing user actions in real time or connecting dozens of independent services, Kafka helps keep everything running smoothly. Today, Kafka is a backbone for many modern systems. It's used by companies around the world to power everything from social media feeds to financial transactions. Its ability to handle real-time data and connect multiple services makes it a key tool for building scalable, resilient applications. If your system needs to move data quickly and reliably, Kafka is often the answer. Sum it all up, Apache Kafka exists because modern systems need a simple, reliable way to move data between services without everything being tightly connected. By acting as a central meeting point for information, Kafka helps developers build systems that are easier to scale, maintain, and evolve. It's a powerful tool for anyone building complex, data-driven applications in today's fast-paced world.